going to work number 1 and number 9 on your predicting products and solubility lab. Number 1, first thing, write your formulas of your reactants correctly. Lead nitrate, lead is +2, nitrate NO3 minus, so there's 2 nitrates for 1 lead. It will be reacted with potassium +1 and iodine minus to react the products or predict the products. I match up the outside with the outside. That will give me a new product of lead iodide. Oxidation numbers remain the same. Lead is a +2, so it stays +2. Iodine is still minus, so there needs to be 2 of them. Checking the state of matter for lead iodide, I go back to the chart, the solubility chart. I'm finding my negative ion. My negative ion is iodine. My iodine I- is soluble in water, except when it has silver, lead, or mercury. Well, in this case I have lead. So therefore, this reaction at station 1 produced a solid precipitate, which was lead iodide. My second product, I will match up the inside with inside. And I get my product of K. Always write the positive first. So my second product is K, which is positive, NO3, which is minus. Anything that has a nitrate on it, or anything that has an alkali metal on it, there's my nitrate. Always, no exceptions, is aqueous. Then I balance the equation. I have 2 nitrates on the reactant side. I need 2 on the product side. That gives me the 2 nitrates. I have now 2 potassiums. So I need to have 2 potassiums on my reactant side. And those remain 1. I did work this one in class, but I'll rework it. Hydrogen sulfide. H is a plus, SO4 is a -2, so the correct formula is H2SO4. It is reacted with sodium hydroxide. Sodium is plus, hydroxide is minus. Outside with outside. Will produce H, OH, check my solubility. Solubility of OH is insoluble, but there are exceptions, and those exceptions are ammonium NH4, an alkali metal, calcium, strontium, or barium. But it has an H, and I'm going to treat H's on my product side, H's that are starting my formula, are going to be like alkalis. If it has an H, it's like an alkali. Therefore, if this is insoluble, since it has an H on it, it is soluble. Therefore, it is aqueous. But since this is an acid-base neutralization, anything on the reactant side here that starts with an H, anything that starts with an H on the reactant side is an acid. So H2SO4 is an acid. If my product has an OH in it, in the reactant side, OH are basic compounds when dissolved. So OH is a base. When an acid and a base react, the product is always water. And when we do the outside with outside, inside with inside, it will show up like this on our paper, and that is water. Water is liquid. I also create a salt, and that is the one that I do the inside with inside. Sodium sulfate. Sodium sulfate. Sulfate is on the upper part. It is soluble in water, except that it has those compounds on it. Sodium is neither one of those, so therefore this is aqueous, and this is my salt. So this state is, for sulfate, aqueous. I need to balance the chemical equation. Alright, so I'm going to start with, well, the only thing I really need to start with, which is either the H or the sodium. So, I have 2 sodiums on the product. I need 2 sodiums on the reactant. That gives me now 2 sodiums and then 2 hydroxides. So I need to get 2 hydroxides. That gives me 2 hydrogens, but I already have 2 hydrogens on the reactant side.